Hi, everyone. This video will talk a little bit more about expected payoffs, expected values, and how to measure risk, at least in some basic examples. So let's start with, this lecture and video and the section in the book are all sort of uh, several examples of computing expected values. So let's just jump in with one of our own examples. So let's say we're trying to insure two cities, let's say small villages. So we're insuring uh, two small villages against flood damage, against flooding. And the first village, so village one, and then we have village two. And village one, if it's flooded, will the insurance should pay off 100 million uh, dollars. And in Village 2, we'll say it has to pay off 500 million. It's a little larger. And now you go to your local meteorologist and um, geologist and discuss a little bit about what the risk or the probability of a flood occurring in these two villages are. So in the first village, so we'll say outcomes, there are four different outcomes. Village 1 floods, Village 2 floods, both flood or neither flood, but we're not going to worry about neither flood because there's no cost, there's no payout in neither flood. So we're just going to look in the cases that occur. So what is our X value here? If Village 1 floods, it's 100 million. I'll just do it in millions of dollars. Say 100, X2, 500, and X3 will be 600 because we have to pay out both villages. And let's say we talk to the meteorologist, the geologist, all of the folks, and we've determined that the probability of one village flooding or village one flooding is 1/100th of a percent. It doesn't happen often, but it does happen. The probability of village two flooding is even more remote. It's 0.01, 0.0011 thousandth of a percent. Both flooding is extremely remote, um, and it's going to be, let's say, 0.110 thousandth of a percent. And so now, so there's the probabilities. What we want to do is we want to, if you're an insurance executive, or if you're what's called an actuary, you'll want to price these policies. So you'll want to see what is your expected payout. In other words, how much over a long period of time would you expect to pay out to these villages for these policies? And that way you can get an idea of how much to price these policies, these insurance policies. So this is just a simple expected value scenario. You want to calculate the expected value, which is P1, let's recall the formula, times X1 plus P2 times X2, 3, plus P3 times X3. And writing this out, we get 0.01 times 100, point plus 0.00 1. I'm already messing up here. So let me let me erase this because hopefully you caught this error that I just made. Um, the probability is not 0.01. I have to convert my decimal or my percentage into a decimal. And so in this case, it's not 0.01, it's 0.00. That would be uh, 0.01. That would be the right percentage or decimal version of this percentage. So this is times 100 plus, um, now here we have 0.00001 times 500 plus point zero 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 one times 600. Oops. Okay, so if you may not be able to, so you can calculate this, but this is going to be point 0.0156, I believe. So now this is millions of dollars, or which is maybe we can, instead of writing it that way, we can multiply. So this is our expected in millions of dollars. But then if we converted into regular dollars, right, this is times 10 to the seventh. So I believe we're going to get 156, two zeros here. So I believe that's what we should be looking at. Yes. So how does this help you? Well, if you're trying to price these policies, you would want to say, well, we should price it so that both villages together are at least paying, um, this amount every year, because that will give us over the long term that will allow us to um, pay for this policy. At the very least, if you're interested in profit, you may want to add some on. Okay, so this gives you an idea of how you can measure risk if you have good probabilities, and you know exactly what or at least what you're going to insure, you know exactly what the payoff is in the various scenarios and the various outcomes. All right, so let's do another example, and you can look in the book for some examples of lottery tickets, but I'm just going to give a simple one. So, so suppose there is a particular kind of game. There is a lottery ticket game, which people have to guess a 4-digit number, which entails guessing a 4-digit number. If you get it correct, if you get the exact number, you win $10,000. If you get all of the digits correct, but not in the right order, you win say $1,000. Okay. So, um, and now let's also make the condition uh, that every digit is different. So we'll say when you guess a four-digit number, um, we're going to make this condition. So there's a condition. So each digit is distinct. So no repeats. Now, in this lottery ticket game, we ask what. So the lottery wants to make um, $3 per ticket sale. So now your task is to price it. So what is the price that we're going to sell these tickets for? So what should be the price for one ticket? So what we have to do here is we have to calculate this expected payoff. That's the goal of this. So we have two different outcomes here. What are our two different outcomes? One is that we receive that uh, the winner receives $10,000. The other is that the winner receives $1,000. And then there's a large probability of the person who bought the ticket receiving nothing at all. So we're going to calculate the expected payoff. We need to calculate the probability of these two outcomes. So task, oops. So we want to calculate probabilities here. And then once we have the probabilities, we can go ahead and calculate our expected value, our expected payoff. So what is the probability of $10,000 payoff of X1 being 10,000 here? And then what is the probability of X2 winning 1,000, like of us having a $1,000 payoff? Well, we have to calculate what are all of the possible outcomes here. So that the total number of outcomes, this is sort of a fair game, total number of outcomes, maybe I shouldn't say that, but okay, there's no particular, wait, this is an equiprobable, that's the word I'm looking for, equiprobable um, situation. Total number of outcomes are all possible permutations of length 4 of digits of which there are 10, 0 through 9. So there's all length 4 permutations of 10 digits. So this is what we would call, like P 10 4, and that's 10 times 9 times 8 times 7. That's the total number of outcomes. So we'll say number of outcomes. And then there is only one that gives us this payoff. In other words, you need to choose exactly one of all of these to get that payoff. So the probability here is 1 over, 10 times 9 times 8 times 7. I'm just going to write it out that way. And on the other hand, how many outcomes are there with which involve rearranging the numbers that you have correctly. So if you have a 4-digit number, that's the winning number, you can rearrange those 4 digits in 4 factorial ways. Uh, there's the number of ways of being in this situation is 4 factorial, but we have to be a little careful here. So it's going to be 4 factorial because we can rearrange the digits in 4 factorial ways of the winning ticket, except for the one way where it's an actual number. So if we got this one possibility, we would win 10,000, the exact right number. But every other way of arranging it there are 4 factorial of them. And so we have this total number of ways, and that's out of all possible permutations. So 4 factorial is 24. 4 times 3 times 2. So this is 23 over this number, which I'm going to leave as such. So now we want to calculate the expected payoff. This is equal to E. This is equal to our P1 times X1 plus P2 times X2. So that's equal to 10,000 over 10 times 9 times 8 times 7 plus 23 times 1,000. So this is 23,000 over the same number, 10 times 9. Now I'm just keeping it out this way because I'll put it into the calculator in a moment. So this gives us 33,000. My apologies. So this gives us a total of 6.56, maybe 650. And we were told that we wanted to make the lottery company wants to make, the state wants to make $3 per ticket sale. So the expected payoff is 650. And if we want to collect an additional $3 per sale, we should add $3 on top of that. And we would just make the price, so the ticket price, I mean, this is really, maybe we should not fudge the numbers too much. We'll say 655 should be $9.55. So it just added 3 to the expected payoff. All right, so this is essentially how you can measure risk using expected values. Is the difficult part of this process is calculating the probabilities. Once you have the probabilities, you go ahead and calculate the expected payout, expected payoff, and then you can add on. That gives you a sense of how much you will expect to pay or receive, depending on the situation. And that can give you a way of pricing or determining whether it's a good deal or a good scenario. Okay.